A quadratic equation is a polynomial equation of degree 2 in a single variable x. Let px be a quadratic polynomial. Then px is equal to 0 is known as a quadratic equation. Some examples of quadratic equations are 3x squared plus 4x minus 5 is equal to 0. X squared plus 10 is equal to 0. X squared minus 2x is equal to 0. The equation in the form ax squared plus bx plus c is equal to 0 is called a quadratic equation in its standard form. Here, a, b and c are real numbers and a has a non-zero value. Here are some examples of quadratic equations in their standard form. Fill in the blanks with the correct values. Fill in the blanks with the correct values. Fill in the blanks with the correct values. Let's see how to formulate a quadratic equation when we have a descriptive situational problem, also called a word problem. A company plans to build a conference room with a carpet area of 500 square feet. The length of the room is 2 feet more than thrice its breadth. Formulate a quadratic equation which represents the relationship between the area, length, and breadth of the conference room. Solution: let the breadth of the room be x feet. It is given that the length of the room is 2 feet more than thrice its breadth. Thus, thrice the breadth is 3x, and 2 feet more than thrice the breadth is 3x plus 2. Thus, the length of the room is 3x plus 2. So, the area of the room is equal to 3x plus 2 into x square feet, as the area is obtained by multiplying length by breadth. Since the carpet area is 500 square feet, we can write 3x plus 2 into x is equal to 500. On simplifying it, we get 3x squared plus 2x minus 500 is equal to 0. And so, the breadth of the conference room satisfies the quadratic equation 3x squared plus 2x minus 500 is equal to 0. Tap the buttons to understand this better with more examples. Fill in the blanks with the correct values. Fill in the blanks with the correct values. Fill in the blanks with the correct values. A quadratic equation can be solved by finding out the factors of the polynomial. Consider a quadratic equation ax squared plus bx plus c is equal to 0. If x is equal to alpha is a solution of the quadratic equation, then it satisfies the equation. We can also say that alpha is a root of the quadratic equation ax squared plus bx plus c is equal to 0. The steps involved in solving quadratic equations by the factorization method are: write the quadratic equation in the standard form. Split the middle term in such a way that when the two numbers are multiplied, the product is AC, and when added, the sum is B. Find the factors by grouping the terms. Solve for the variable in each factor of the equation. Use the factorization method to find the roots of the equation 3x squared plus 4x plus 1 is equal to 0. The equation 3x squared plus 4x plus 1 is equal to 0 is in the form ax squared plus bx plus c is equal to 0. Now we split the middle term so that its coefficient b, which is 4, is expressed as the sum of the coefficients of the two new terms, and the product AC is equal to the product of their coefficients, that is, 3 into 1, which is equal to 3. We will find that the coefficients 3 and 1 meet these criteria. Thus, the middle term can be split into 3 and 1. 3x squared plus 4x plus 1 is equal to 0. 3x squared plus 3x plus x plus 1 is equal to 0. It can further be simplified by grouping the terms as 3x into x plus 1 plus 1 into x plus 1 is equal to 0. Taking out the common expression x plus 1, we get x plus 1 into 3x plus 1 is equal to 0. On putting the factors equal to 0, we get x plus 1 is equal to 0 or 3x plus 1 is equal to 0. Thus, x is equal to -1 or x is equal to -1 by 3. So, x is equal to -1 and x is equal to -1 by 3 are the roots of the equation. We can verify that these are indeed the roots of the equation by substituting x is equal to -1 in the LHS of the equation. 3x squared plus 4x plus 1 is equal to 3 into minus 1 square plus 4 into minus 1 plus 1 is equal to 3 minus 4 plus 1 is equal to 0 is equal to RHS. Similarly, if we substitute x is equal to negative 1 by 3 in the LHS of the equation, we get 3x squared plus 4x plus 1 is equal to 3 into negative 1 by 3 square plus 4 into negative 1 by 3 plus 1. On solving, we get 0, which is equal to RHS. Tap the buttons to understand this better with more examples. Let's solve this word problem. There are two squares such that the sum of their areas is 468 square meters. The difference of their perimeters is 24 meters. Find the sides of both the squares by formulating the quadratic equation. Solution: let the length of each side of the smaller square be x meters. So, the perimeter of this square is 4x meters. Since the difference of the perimeters of the squares is 24 square meters, the perimeter of the second or larger square is 24 plus 4x meters. The length of each side of second square is equal to 24 plus 4x upon 4 is equal to 6 plus x meters. Also, the sum of their areas is 468 square meters. So we can write x square plus 6 plus x whole square is equal to 468. On simplifying it, we get 2x squared plus 12x minus 432 is equal to 0. On dividing both sides of the equation by 2, the quadratic equation becomes x squared plus 6x minus 216 is equal to 0. Now we can solve this equation to find out the sides of each of the squares. On splitting the middle term, we get x squared plus 18x minus 12x minus 216 is equal to 0. On solving it, we get x plus 18 into x minus 12 is equal to 0, which implies x plus 18 is equal to 0 or x minus 12 is equal to 0. X is equal to minus 18 or x is equal to 12. Tap the button to understand this better with an example. Can all quadratic equations be solved by factorization? Consider the quadratic equation x squared plus 3x plus 1 is equal to 0. Here, AC is equal to 1 and B is equal to 3. There are no two rational numbers whose product is 1 and whose sum is 3. So, we can't factorize the quadratic polynomial to solve the equation. So, we see that we can't solve all quadratic equations by the factorization method.
Enter a quadratic equation and see how the factorization method can be used to solve it.
Fill in the blanks with the correct values. 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 Let's summarize what we have learnt in this topic. If we can express the quadratic equation ax squared plus bx plus c is equal to 0 in the form px squared minus d is equal to 0, where px is a linear polynomial and d a constant, then we can find the roots of the quadratic equation. Consider px squared is equal to d. Taking the square root on both sides, we get square root of px squared is equal to square root d. On simplifying it, we get both the positive and the negative square roots on the RHS. Px is equal to plus minus square root d. And so, we get two linear equations in one variable. Px is equal to square root d and px is equal to negative square root d. By solving both of these, we get the two roots of the quadratic equation ax squared plus bx plus c is equal to 0. Consider the quadratic equation x squared plus bx plus c is equal to 0. Here, a is equal to 1. We can represent x squared plus bx graphically, or rather geometrically. The area of a square of side x is x squared, and the area of a rectangle of length x and breadth b is bx. Thus, the total area of both the figures is x squared plus bx. If we split the rectangle into two rectangles each of dimensions b by 2 into x and rearrange them, we get a shape which is almost a square, with a small square piece missing. The area of this new shape would also be x squared plus bx. The edge of the small missing square is b by 2, and therefore the area of the missing square is b by 2 whole square. So, x squared plus bx is equal to x plus b by 2 whole square minus b by 2 whole square, or x squared plus bx plus b by 2 whole square is equal to x plus b by 2 whole square. So, we see that adding b by 2 whole square to x squared plus bx gives a perfect square, x plus b by 2 whole square. Now, again consider the equation x squared plus bx plus c is equal to 0. On taking the constant to the other side, we get x squared plus bx is equal to negative c. Next, add b by 2 whole square to both sides. X squared plus bx plus b by 2 whole square is equal to negative c plus b by 2 whole square. Substituting x squared plus bx plus b by 2 whole square with x plus b by 2 whole square in the equation, we get x plus b by 2 whole square is equal to negative c plus b by 2 whole square. So, we have successfully changed x squared plus bx plus c is equal to 0 to px squared is equal to d, where px is x plus b by 2 and d is negative c plus b by 2 whole square. Now, we can easily find the two roots of x squared plus bx plus c is equal to 0. We worked with an equation where the coefficient of the x squared term was 1. Let's see how we complete the square for an equation where a is not 1. Consider the quadratic equation ax squared plus bx plus c is equal to 0. We first divide both the sides by a to get rid of the coefficient a in the term x squared. Thus, we get x squared plus b by a into x plus c by a is equal to 0. We can also write it as x squared plus b by a into x is equal to negative c by a. As we saw earlier, we now need to add the square of half of the coefficient of the term x. So, now that we have a coefficient b by a for the term x, we need to add b by 2a whole square to both sides. X squared plus b by a into x plus b by 2a whole square is equal to negative c by a plus b by 2a whole square. The first three terms can also be written as x plus b by 2a whole square is equal to b square minus 4ac upon 4a square. We can see this graphically as To find the roots, we need to remove the exponent by taking the square root on both sides of the equation. We get the values of the two roots as x is equal to negative b plus minus square root b square minus 4ac upon 2a. By computing the two square roots, one positive and the other negative, we get the two roots of the quadratic equation ax squared plus bx plus c is equal to 0. Tap the buttons to understand this better with more examples. We know that the quadratic equation x squared plus 3x plus 1 is equal to 0, with ac is equal to 1 and b is equal to 3, cannot be solved by the factorization method. Let's see if we can solve it by completing the square. To complete the square, we add b by 2a whole square, which is 3 by 2 whole square, to both sides. X squared plus 3x plus 1 plus 3 by 2 whole square is equal to 0 plus 3 by 2 whole square. Using the identity a squared plus 2ab plus b squared is equal to a plus b whole square, we get x plus 3 by 2 whole square plus 1 is equal to 3 by 2 whole square. On solving it, we get x is equal to negative 3 by 2 plus minus square root 5 by 2. So, x is equal to negative 3 minus square root 5 by 2, and x is equal to negative 3 plus square root 5 by 2 are the two roots of the equation. So, now we can see that this quadratic equation has irrational roots. Quadratic equations with irrational roots can't be solved using the factorization method. But all quadratic equations can be solved by using the method of completion of square.
enter a quadratic equation and see how the completing the square method can be used to solve it.
Fill in the blanks with the correct values. 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 We know that using the method of completing the square, we get the roots of the quadratic equation ax square plus bx plus c is equal to 0 as x is equal to negative b plus minus square root b square minus 4ac by 2a. This is called the quadratic formula. It allows us to quickly compute the two roots of a quadratic equation without taking the trouble of factorizing or completing the square. Thus, the quadratic equation ax square plus bx plus c is equal to 0 will have two real roots if b square minus 4ac is greater than equal to 0. The steps involved in solving the quadratic equation by using the quadratic formula are: compare the provided equation with the standard form ax square plus bx plus c is equal to 0 and find out the values of a, b, c. Substitute the values of a, b, c in the formula. X is equal to negative b plus minus b square minus 4ac upon 2a. Solve for both the positive and the negative values of the square root. Tap the buttons to understand this better with more examples. Fill in the blanks with the correct values. 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 Let's summarize what we have learnt in this topic.